Okay. We are live on YouTube. So hello, YouTube world. I know there's a few of you out there already. Welcome to the May 4th ClickHouse Bay Area Meetup. We'll get started in just a second. Hey, Tim, welcome.
Hey, how's it going?
It's doing great. All right, so let me set a couple other things. Let's see, we're still, so Federico, you'll be doing the talk for on Hydrolix, and Tim, you'll be doing this the Stream.io or Stream Native, excuse me, talk. And I've got one. I'm going to do a short one ahead of you. Let's just wait a couple seconds. I want to make sure that other people can get in. Let's just check here how many attendees. So we don't have too many attendees on Zoom. They're kind of slow to come in today. We'll give them a couple minutes. While we're doing that, let me suggest the following. Federico, I think I have you set up as the next talk. Do you want to go ahead and just practice sharing your screen? And let's just make sure that that you're able to share.
So can you see my screen okay? You see Hydrolix?
It's beautiful. It's completely beautiful. Yeah, that's lovely. And just flip a couple slides. Excuse me.
That's good.
All right.
Nice.
Yeah. Yeah, I like the ping. I like the ping pong. That's a nice touch. Just checking the video works. Hey, Tim, you want to go through the same exercise? Hey, everybody! If you're getting in here, we're just getting set up. Oh my goodness, that's a nice.
Very nice.
Oh, that looks really nice and flip. Yeah, perfect. All right, welcome to both of you. I think we're getting close to. I'm going to give people a couple more minutes to get in here. In the meantime, what I'm going to do is everybody who's in here who's on Zoom, you can actually talk because I'm going to allow you to talk. If you want to unmute yourself and say hello, we always like to have people come in and talk about what they're doing. So welcome everybody. So if anybody wants to speak up, tell what they're, introduce themselves, where they're from, you're welcome to do so. Don't be shy.
Hi, this is Jay.
Hey Jay, how's it going?
Good. How are you?
Good to see you again.
Yeah, thank you. Yeah, thank you for this good informations, and then this Zoom, Zoom, and then this meeting. Yeah, this will be very helpful, and then they were helpful, and then it will be helpful. And I am from Palo Alto Networks, so we are trying to evaluate the ClickHouse.
Good. Welcome. It's great to have you on board. Let's see. I'm going to go ahead, and anybody else who'd like to speak up and introduce themselves. Hey, Kanti. Actually, my colleague Kanti is here. I'm going to promote you to panelist. You'll be fully enabled. So this is up. Hey, Marty, how's it going? So anybody else want to do intros here? We'll take a couple more minutes. We've got also folks on YouTube. Hey Tim, I see you on as an attendee. Are you? But you're also on as a panelist, correct? Or no? I see a Timothy Spann on as a. Oh, okay, that disappeared. Great. All right, more people coming in here. Welcome everybody. So if you can see my screen, this is the ClickHouse May 2022 virtual meetup. So once again, we're online, and we're going to do 3 talks today. We're going to be talking about ClickHouse. We're going to, and I'm going to do a talk on if combinators, which are one of my, well, I have a lot of favorite features in ClickHouse, but this is like clearly my top one. Right now, it's my current crush. We're going to talk about Hydrolix and ClickHouse. That's Federico is going to be doing that, talking about how they built this new database by forking ClickHouse and what they learned in doing that. And then we have Tim Spann is going to talk about streaming into ClickHouse with Apache Pulsar. So we have a great set of things coming up. We're live streamed. We have a bunch of people coming from who'll be coming in from YouTube. So welcome to everybody. Just 1 minute. I'm going to go ahead and turn on the, make sure we've got Zoom recording on here. So Zoom recording is about to start. So just 1 second here. Okay, great. So Zoom has got it. We've also got the live stream, so we should have good video one way or another. Anybody else who wants to chip in before we dive into the meat of the meetup? Ramazan, welcome. I see a lot of friends out here, so it's good to see you all again. Okay, let me just dive in. We've got folks on Zoom. We've got folks on YouTube. Let me talk a little bit. Just once again, this is the ClickHouse May 2022 virtual meetup. My name is Robert Hodges, and I'm one of the organizers of this meetup. I work for Altinity, and I'm CEO, but that's my day job, but I'm really a database geek. I've been doing it for many years. And I have a few announcements that I'd like to just run by you, just so you know what's going on. Very interesting. We have actually these announcements involve offline events, I'm happy to say. So in May, in case you are not aware of it, Percona Live is coming to Austin. And for folks who are in the open source database community, this has always been a great conference. It's in Austin downtown. There's still time to grab a ticket and get out there. There will be a lot of talks on all kinds of open source databases. Of course, Percona is sponsoring this. They're very big on MySQL, of course, Postgres, MongoDB, and there will be ClickHouse talks there as well. Among other things, we're going to be talking about some ways to replicate data very quickly into ClickHouse. It kind of keys on some of the stuff that Tim will be talking on later. So that's Percona Live, starts on May 16th in Austin. Another interesting thing coming up at the end of June, the Databricks conference is coming up. That is called Data Plus AI. It's in San Francisco, another offline event. And I'll be doing a talk there on trillion row data sets hosted on ClickHouse, and how to give people end user access to them, to allow them to see the source data and work with it. It's called Opening the Floodgates. It's a really exciting talk. And partly because dealing with a trillion rows is really scary. I mean, just generating the data to do the examples is already an interesting project. So that's coming up. And then we are going to be in July, a couple of events. We are planning a data on Kubernetes in-person event somewhere in the Bay Area. So if you use Kubernetes and you're interested in data, there's a DOK community. It's pretty popular, has at this point several thousand members, does piles of talks, very heavily into all aspects of running databases on Kubernetes. And what we're going to do is to try and do an in-person get-together in the Bay Area. So if you're interested in data in Kubernetes, watch out for that. And if you don't know about the Data on Kubernetes community, definitely check it out. It's a really great organization. And then finally, also in July, we'll have the next meetup for ClickHouse. I'm looking for talks. I've got one candidate already. We'll probably do a talk on replication, sort of specifically from MySQL to ClickHouse. One of my colleagues, Kanthi, has been doing a bunch of work on this, and we'll be sharing some of the stuff. This is all open source and should be pretty interesting. I think that's it for announcements. Any other announcements that anybody wants to make before we dive into the talks? Let me just check out on YouTube if we've got anything. Hang on 1 second here. Move this out of the way. Okay, great. Looks like people can listen. We've got about a dozen people out on YouTube in addition to the crowd here. So welcome, everybody. With that, I'm going to go to the first talk, which is me. So let's see, let me get this to be a slideshow. This is a short talk, probably should go about 10 minutes. And as I say, it's this, this feature that I have been very interested in. I sort of learned how to use it recently, and I want to share some of the stuff I use it for. So it's called ClickHouse If Combinators for Fun and Profit. And let me just do some quick intros on this. This is, as I say, a really short talk. It's not a huge part of ClickHouse, but it's an incredibly useful one. So just a little bit about me again. I've been working on databases for actually almost 40 years. I tend to say 30 plus because it doesn't make me sound so old. But it's been everything from pre-relational databases to things like Sybase, Oracle, MySQL, then now analytic systems. I work with a team of amazing engineers with just centuries of experience collectively on database and applications, particularly strong on analytic systems and, of course, ClickHouse. And then as a company, we do support and services. We have something like 200 customers, about 2/3 of them running on-prem or in self-managed environments, and then 70 or so running in the cloud, which Altinity.cloud. We also wrote the Altinity Kubernetes operator for ClickHouse. Some people on this call, no doubt, are using it already. That's a piece of software that we all know and love. And actually, it's just one of a number of things that we're working on this year, and we'll have more to say about that later. But that's enough marketing. Let me just jump in and talk a little bit about, and by the way, if you have questions, feel free to throw them up in the, you can even jump in and talk about them. Let me just make sure I've got the question and answer box up here. 1 second. Sorry, I'm struggling with the Zoom controls. You can throw them in the Q&A box or, excuse me, just put them in chat. So what, I think everybody on this call probably knows about aggregation functions because they're probably the single most important feature of ClickHouse. I mean, the whole point of data warehouses is to be able to scan, a few billion rows and come up with a very small amount of information that gives you some insight into the data. And aggregates, which is to, sort of different, basically different ways of reducing measures across all these billions of rows to things that humans understand easily, are a fundamental part of that. So for example, just counting the number of things that meet a certain condition, getting min and max values, sums, averages, uniques, that's the number of distinct values, getting histograms. There's just all kinds of cool things. What's I think less well known, particularly among people who are new to ClickHouse, is that you can actually make these. Normally, when you do aggregates, you just get a value in, and the aggregate will get computed for every row. Well, what these if combinators do is they allow you to only have the aggregate computed on a row if it meets a certain condition. And they're really simple. All you do is you take an aggregate like count and you add the word if, capital IF, to the end of it. And then you add a condition. So it's like an extra argument that goes on there at the end. In the case of count, there's 0 arguments, so it's the only one. But if you want to only compute the min under certain conditions, you give the column that you're computing it on, or excuse me, the expression, and then a condition under which you should do it. So that's how it works. So you can actually use these on anything, any aggregate function. You can just stick if on the end of it, and it will have this behavior that will only do the aggregate under that when that condition is true. This doesn't sound very great, but it turns out to be an incredibly useful feature. I'm going to give you 3 examples in this quick talk. The first one is, let's talk about dirty data. And we'll have a couple examples around this, but the first thing is finding it. And I think that many people who are, do data exploration are used to using histograms to figure out what the distribution of the data is. And I have kind of a love-hate relationship with histograms in ClickHouse. And the love part is, yeah, it can sort of figure out, because basically what a histogram does, this is an example, is it basically bins your data into sections and then gives you an idea about how many of your values fall in each section. So for example, if you have, we're looking at, in this case, taxi fares, And this is coming out of the New York taxi cab data set. And it turns out there's one value that's really at integer min. And then there's a bunch of values which are at or close to very large integer values. You can see that from this histogram. And then most of the values actually fall in the middle. As it turns out, most of them are, in fact, values that are, let's see if we can read this, that are kind of in the middle range of the fares, which are, from minus 1 million to 177,000. What you can already see is this is incredibly hard to read. So it's not something that just, this is the hate part. It's a real pain to sort of extract useful information out of this, unless you're really good at statistics. These things just give you kind of a hint about what the data looks like. They're also kind of slow. So this is running on 1.3 billion rows, and it took almost 7 seconds to do the computation. So that is useful to give us some information, but it turns out with these if combinators, there is a better way to do this. And that is that the histogram is going to figure out the bins itself, but you can actually use these combinators to do your own bins. And here's an example. So what I'm going to do is create 4 bins of these fare amounts, and I'm going to count the number of values less than 0. I'm going to count the number of values between 0 and 100, between 100 and 1,000, and greater than 1,000. And that's what this syntax looks a little complicated when the first time you see it, but it's totally simple because the condition is just a SQL condition on the column, and then that's it. You give it a name, you run the query, and what we get, instead of that kind of complicated array output, which we really have to parse very carefully, we get very simple bins, which we've just defined ourselves. So for example, we can see that there are 128,000 or almost 129,000 fares that are less than 0. This is probably garbage data. So if we're thinking about data cleaning, that tells us, hey, these are fares that we can just exclude if we're actually if we're actually doing averages, sums, or min, max, anything like that. We can just keep these values out. And then there's fares that are above 1,000, many of them way above 1,000. Again, we see 373 of these. So easier to read. So a very simple way of getting the data. The second thing is it's fast. It's under a second. So this is much, because it turns out counts are just very, very fast aggregates. And so in this case, we're basically doing 1 count per row. It's about the same performance as if you ran down all the rows and counted them. So this is a very common use to bin things, and you can then begin in some cases to think about replacing other more expensive aggregates. So that's use number 1. Here's another one. Searching, pivoting data. So let's start with a concrete example. And here, what we're going to do is select pull requests, sort of people opening pull requests and people starring projects. And we're going to do this and group it by year and then sort it by year. And the way that we do this in traditional SQL is we're going to basically do a group by, order by. We have an in here, which is going to restrict it to those 2 types of events. And then we get the output shown below. And this is fine. It gives you the information, but it's not super readable. What we'd really kind of like to do is what's called a pivot, where we take those event types and we actually make them into columns and then show the counts and then show the counts under them. This is something you can do very easily in Excel, but is actually quite hard to do in SQL. So here's an example of pivoting. We can rewrite this a little bit where we can use count if, and in this case, we're going to count the event types for pull request and watch event and just give them column names. And what you get then is you get things still grouped by year, because we continue to group by year. Actually, it should have sorted by year, but it seems to have come out right. And we get the PRs and the stars shown in this really nice, sort of in this really nice, much more readable format. So that's a second example of something you can do with these if combinators, pivot data. And by the way, it's important to know that even if you say count if, it's important to know that you're still going to read the rows even if you don't do the count. So as a result, I still have this where, event type in. I still have that condition that I had from the previous query because that just allows ClickHouse to skip a bunch of data. So, so that's actually a kind of a performance hint. If I had not done this, this would have taken a lot more time because it doesn't save time when you're not doing these counts. Okay, so that's that is the pivoting. And then one final example is one of the things, if you're familiar with SQL, is you can't really have multiple conditions. You have a filter condition in your where clause. You can have a bunch of them, but the thing is they apply to all rows. And so this is an example of one of the more sophisticated things you can do with these if combinators is you can now assign different conditions to column aggregates, but have it in the same scan. So we're running down the entire length of the table, and what we want to do is we want to take averages of the passenger count, so the number of passengers in the taxi as well as a fare amount, but we want to put unique sort of differing conditions on them to filter out the bad data. So the passenger count, we're going to assume that anything under 10 is okay. Anything greater than that is either a college prank or bad data. With fare amounts, anything that's the fare amount has to be between 0 and 500. Otherwise, we consider it an outlier and we'll organize it or ignore it. And in this case, we then get these cleaned up averages. We still get a full count of the rides across the entire thing, but these are cleaned up averages, which hopefully give us a better sense of what data is, what the valid data actually looks like without us having to do multiple queries, for example, to clean stuff up, or like another horrible thing that some databases force you to do is actually do multiple queries and then do joins to get this information put together. So ClickHouse, this is a very interesting and efficient way of using these. And that's my examples. What's useful is there are other tricks you can do with this. It's not a tremendously sophisticated feature, but you can go ahead and you can look up other ways to use it. You can look up in the ClickHouse docs, but to be frank, as broad as the coverage is, the coverage of this particular feature is not very strong. It really doesn't give you a sense of what you can do with it, and it has limited examples. Overall, probably the best source of information that I've found is actually in the Altinity knowledge base. And we use these a lot. We have a lot of examples in there about how to use these in system tables. They turn out to be very useful to make system table information useful. Plus, there's some clever tricks like talking about how to combine them with what are called simple aggregate functions, which is a topic that's too complicated really to explain in a couple of slides. And then finally, this is, whenever you're looking for things that are possible in ClickHouse, you always can go look at the code base, and the best place to look for anything in SQL is in the tests. So here's an example of where I'm CDing into the, moving over into the ClickHouse source code tree, running down it. Oh, that should be actually ClickHouse tests, I think, not source tests. That was a copy paste error. But then you can just grep, just do grep -r, looking for the different, whichever one of these combinators you're interested in, and then tests will pop up. They will show you what is possible to do and why. So, all right. So with that, thank you. That's the end of the talk. I'll take questions. I have one which is kind of off topic about this. So ClickHouse so the question is, and I'll just address this up front. The question is, we're wondering if you have any insight into the state of ClickHouse development, given the Russian base routes in the war in Ukraine. There's two things about this. One is the core committers of Russia are no longer, thanks Anselmo, he just posted the correct link or the correct development. The core committers of ClickHouse are now all in the Netherlands. I don't know if that's generally known, but they are, they are, yeah. So Ramazan just pointed a list, but I think this is an important topic. So the core committers are all in the Netherlands. Second thing is ClickHouse for a long time has been a worldwide project. It has, last year, I haven't run the numbers recently, but I think last year it had over 400 individual sort of unique committers from all over the world. And so it is a very, very large open source project, and it is bigger than any. Yes, it's true that it developed originally in Russia, but it is open source, and now it's this enormous open source project. It's actually one of the at this point, I believe, is the largest single open source database project on GitHub. The numbers are actually quite staggering, the number of unique contributors. It was about a year and a half ago, it passed Elastic, which was the previous 800-pound gorilla. It's a really big project. And our hope, and I think if you read Alexi's comment in the link that Ramazan posted, as Alexi said, the open source community, we built this for the open source community, and certainly Alexi is the person who did more than anything else to create this community. Our focus is to build software that works for everybody. And, obviously, the war that's going on is a terrible, terrible tragedy all around. But we think that this is an open source project that is bigger than the event in any single country, as horrible as it is. Anyway, that's probably more than you wanted to hear, but that's sort of my take on it. All right, I don't see any other questions about this feature, so I hope this was interesting. I'm going to kill my share and bring up Federico, who is going to talk about Hydrolix. So Federico, let me just find my, find the control here, and I'm stopping the share. So go ahead and you can go ahead and share and.
Cool. Can you hear me okay?
Perfectly. Go for it.
Okay, cool. So my name is Federico Rodriguez. I am part of the core team at Hydrolix, and this talk is about how at Hydrolix we are implementing custom storages for querying the cloud. And yeah, so I spend a lot of my time buried in the ClickHouse code base, as I imagine many of you do as well. So very grateful to be here, and I do spend a lot of time, just like you showed, Robert, grepping and reading and absorbing the very large and complex code base that is ClickHouse. So I just wanted to give a quick thank you to you personally, because your blog posts have really offered a much needed companion to just reading raw code. So it's very useful to have a guide when traversing these things and explaining some key elements and principles. So thanks a lot. I really appreciate it. So I'm someone who likes to see the bites. I bet some of you are too. I consume abstract ideas way better if I can pair that abstract idea with something more concrete, or even if it's very simple. If it's concrete, I can understand it better. So the approach of my talk today is to ping pong, thus the GIF, between Hydrolix from this 10,000-foot view, presenting some of the big problems, and our solutions from a kind of abstract, phrase-heavy way. And then I wanted to dive into something seemingly tangential but concrete. So we're going to roll up our sleeves and at least go through the motions of making our own custom ClickHouse storage. So the hope here is to maybe refresh some of you or enlighten some of you on how ClickHouse interacts with its storages, going from query to result. And then as a pleasant side effect, you'll understand the foundation that Hydrolix, the core of Hydrolix, is built off of. So let's zoom out first, and I'll talk about Hydrolix at a high level. We are a cloud data platform built to be truly cloud native. So all of your data exists purely in cheap cloud object storage. At this moment, this includes Amazon and Google clouds, but the architecture is meant to be plug and play. We also deal with append-only time series data, or maybe append mostly, I should say, because we do have support for alter table. We have decoupled compute from storage. So here's one of those phrases that we are going to get into more a bit later. And we are trying to alleviate a common problem that many companies that have a lot of data have, which is we want to keep costs low, we want to not throw away data, and we want to remain performant. So at Hydrolix, we're building tools to help people basically query and keep their data, their huge data sets in a cost-effective way. So how does Hydrolix use ClickHouse? Okay, so there's this great quote from the movie Shakespeare in Love, where the actor playing the nurse is asked, "What is Romeo and Juliet about?" And the actor replies, "Well, it's about this nurse." So similarly, if you were to ask Hydrolix, "What is ClickHouse about?" We would reply, "Well, it's about this computation layer." So from our point of view, what many may find the main characters of ClickHouse, their merge tree, their aggregating merge tree, the storage engines that allow for speedy reading and writing to disk, we are ignoring those for the most part, and we care mainly about ClickHouse's computation layer. So great, we've hit an important abstract concept here, a computation layer. That can mean a lot of things. We are dealing with computers after all, so I think it's a good time to start our tangent. So let's imagine the following scenario. Say we have this new idea for storing strings. Okay, so we've maybe come up with some awesome new compression algorithm, and for lack of a better name, let's call it Cool Strings DB. And the main point of our hypothetical scenario here is that ClickHouse doesn't store strings in this amazing way, and I want to show the world my cool strings. And I want to use ClickHouse as the SQL engine or the computation layer. So we're going to fork ClickHouse and we're going to run some queries on our cool strings. And once again, for purposes of making things simple, we're just going to store strings only because strings are cool. So the main approach here is we're going to write our own objects that inherit from ClickHouse interfaces and override certain functions. So let's begin with our cool strings storage. It inherits from iStorage, the interface, the ClickHouse interface here, and we override the very important read method. So this function is going to be called by ClickHouse during the execution of the query, and it is the first interaction between our cool strings, our custom implementation, our storage implementation, and ClickHouse. So when does ClickHouse call this function? So what I want to do right now is do a high-level overview of what happens between receiving a query and ClickHouse calling storage read on us. And so I'm gonna speed through this. So don't worry if it's not 100% absorbed, but I just want to give a general idea of what's happening on ClickHouse's end and what we have to work with by the time storage read is called. So let's say a query comes in here. This is select all strings in the MyString column that contain the word cool. So in this case, those sequence of characters, select, MyString, et cetera, those are sent via TCP or HTTP to a handler, which calls execute query, in which the query string is parsed into an abstract syntax tree. This is the tree representation of the SQL query. An interpreter is then chosen. In this case, the interpreter select query is chosen to handle this particular query. And it is responsible for running an analysis of the AST and coming up with an actions graph. So for example, we can express what's in the where condition, the position function. That is an action to be performed on the MyString column. And actually, if you're looking really closely, there are two functions that are being performed in the where. Maybe you see them. This is actually the output of the position function, which is being piped into the input of the not equals function. So hopefully you can start to see that a graph can be made from this, right? With directed edges and dependencies between the nodes. Like I need the position to be calculated before I can do a not equals on it. And by the way, you can see the actions of any query by prepending explain actions equals 1. It's a very, very handy little trick there. So then tree rewriter rewrites the AST. It optimizes the AST according to certain optimizations. So an example of one of them, let's say you're calculating both sum of a column and average of a column somewhere else. You don't need to have these be separate, right? You can rewrite these as one single function because in computing the average, you are getting the sum. So this can be rewritten as sum counts, actually, is the name of the function. And other optimizations include logical expressions optimizations, like let's get rid of tautologies that might be in there. Let's execute any scalar subqueries, etc. Then ClickHouse runs execute on the interpreter, and we get a pipeline, and that will get us into the first stage of query execution, execute fetch columns, which finally executes our storage read. So it calls storage read on us. So yeah, there's a lot here. There's a lot more that I didn't talk about, but hopefully what you can glean from all of this is that ClickHouse receives a query, it parses it, it rewrites it, it optimizes it, and all of this happens before it calls storage read. And along the way, of course, if there's any errors, it handles those errors. So maybe I wrote my SQL syntax wrong, and it will nicely tell me that that's wrong. So let's get into what we want our custom cool string storage read to do. So let me just point out two more things about the read function. The first is that ClickHouse is passing us a query info. So this object is basically all the distilled optimizations and analysis that I talked about in the previous slide. It's distilling it into this select query info object, and it's being handed to us to use if we want to in the read implementation. So this will come in handy later. The second important thing I want to point out here is that our read function needs to return a pipe. So pipes are a very literal abstraction in ClickHouse. A pipe is a piece of a query pipeline. More formally, it is a set of processors. And the type of processor here that read needs to return is a source processor. So ClickHouse uses the source and sink abstractions to give directionality to our data flow. So a source is a processor we're reading from, a sink is a processor we're writing to. But okay, in our case, I want to put all of that aside, and I want us to think of storage read having the main responsibility of returning a big red button. So this big red button is something that we're going to build, and whenever ClickHouse wants to press it, it will get a ClickHouse block from our storage, from our cool strings data. So we need to build our own source object that storage read will return. And here we have a cool strings source that once again inherits from a ClickHouse interface and overrides functions that ClickHouse is going to call on us. I hope this pattern is becoming clear to how we're interacting with ClickHouse. The heart of the source implementation is the generate function. So the generate function is our big shiny button. It is when ClickHouse calls generate on us, our mission is to grab data from somewhere and produce ClickHouse blocks, where a block is the main unit of data processing in ClickHouse. It's a container that's stored in memory for a set of columns that may or may not have a bunch of rows. I'm sure many of you understand this already, but I just want to kind of reiterate it. And also, yes, this is returning a chunk, but for this talk, let's think of chunks and blocks as interchangeable. But okay, so there's something I really want to reiterate here. We can grab data in any way that we want from wherever we want, as long as we can deliver to ClickHouse a valid ClickHouse block. So when ClickHouse hits the button, we can pull from a file, we can run some decompression codec, and we can get a handful of strings and then make a ClickHouse block. Cool. So how do we make a block? as the famous saying goes, teach a man to fish and they'll eat for a day. Teach them to make a ClickHouse block and I don't know, they'll launch a startup based on top of ClickHouse, I guess. So let's learn how to generate blocks. Going back to our query, we are selecting the myString column from a table that we could imagine looks something like this, with a few other columns, the ID column and another row column. And so for the row that contains the myString A, it has the ID ID-1, and then there are rows BB, CCC, DDD. So let's work backwards and imagine we already have our ClickHouse block and we can call some functions on it. So the first step is we're going to pull one of our generic I columns out of the block, and we're going to cast it to a DB column string because we know all of our columns are indeed strings. We can then call getChars on it and see something pretty interesting. We see a single string, A, B, B, C, 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 D, 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 all the rows are being stored as a single contiguous string in the block. Okay, so that's cool, but how do we know which row is which? Well, we can call get offsets on the string column. We see 2, 5, 9, 14. So that should tell us where the offset of each row ends, except it doesn't, because 2, okay, maybe that's one indexed and that's the B, but if 5 puts us on the second C. So let's print out the hex representation of each character here using FMT. And because I did promise you bytes after all, here you go. You can see, for example, the lowercase a as the number 61 in hex, etc. And once we realize that each string is indeed null terminated, then, okay, these offsets start to make a bit more sense. So we could almost end our custom storage implementation here. I mean, assuming we have our own way to pull our strings in whatever format they exist. But as long as when generate is called on us, we can basically fill up 2 arrays, right? A character array of all the rows concatenated together, and an integer array of the offsets where those rows should end. We can query our custom storage, right? We can actually run this select query and hand it to, as long as we're handing ClickHouse every single string we've got in blocks, and ClickHouse will return results with only the strings that contain the word cool. So in this case, what happens in between generating blocks and getting this result? Well, we're calling the position function, which finds the position of the needle cool in the haystack, which is a single row of our table, right? That sounds pretty simple. I'm sure anybody could, any one of us could write it, but let's pull up the implementation. This is the case-sensitive ASCII string searcher implementation specific to architectures which allow for SSE instructions. This is what position calls under the hood. And what we can see here is ClickHouse's computation layer in full force, right? What may seem like a basic function on the surface. I've got a row, it's a string, does it contain this other string? ClickHouse can optimize this because of what we showed in the previous slide. So this function is going to explicitly use vectorized instructions here. So instead of searching for a needle in a single row haystack, character by character, what these instructions are doing is we're looking at the entire column, the get chars that we filled in the previous slide. And we're looking at that entire column as the haystack and operating on it 128 bits at a time in parallel. That's great. Also, I have to say that of course, functions are not the only part of ClickHouse's computation layer that we're now able to leverage for our cool strings. I can run this group by query, for example, and I get all the functionality and speed of ClickHouse's aggregation methods, including the brand new feature that I believe guesses at the hash table sizes for group bys, all kinds of great stuff that we now get for our cool strings. So I just want to look at what we've got so far. A query comes in. ClickHouse does some rewriting and optimizing, gets everything ready, and then calls storage read on us. And in storage read, we return this all-powerful source object that gives ClickHouse the red button of generate. And ClickHouse calls generate over and over and over, running actions on each block, and building results as it goes until finally we are delivered a query result, or in the case of TCP, we are streamed one. So if you're connected via ClickHouse client, you've actually been streamed this. It's not all at once. So at the moment, we are gathering all of our strings and handing them to ClickHouse in blocks, regardless of the query. And then ClickHouse is using this awesome vectorized execution and columnar storage. All of that's great, except it does not scale well. I do admit that. So one idea to improve our storage is to downsample the blocks that we hand ClickHouse using information from the query, because we don't need to hand every single one of those blocks. Remember that when ClickHouse calls storage read on us, in its call to read, it is handing us this select query info object. Inside of this select query info object is the AST, the rewritten optimized AST. So there's this great feature. You can do explain AST graph equals 1. You can prepend that to any query. And what ClickHouse spits out for you is the AST in graph viz format. And then you can throw that into an interpreter. I found one online, and you can get cool graphs like this. Yay. So I'm not gonna do a deep dive here, but hopefully just seeing this AST already gives you an idea of how we could walk the tree, pick out some useful information from the where section, let's say, and maybe, I don't know, we could implement an inverted index in which we are doing a full text search. But whatever we do, ultimately, we have an opportunity here to narrow down the blocks that we are giving to ClickHouse considerably by filtering using information from the AST.
Federico, if you don't mind me jumping in, because this picture is so cool, how does that picture compare to the graph you get when you do explain on a query? Because it's not the same.
This is explain. This is running explain AST. With graph equals 1. So are you saying just running explain graph equals 1?
I'm thinking explain, yes, explain select, as opposed to explain AST. So this shows you the AST of the query, but it doesn't necessarily, if you do an ordinary explain, it's showing a different graph, which is, I think, the actual implementation plan. But
yes, it's showing the query plan. Exactly.
Okay.
Yeah. And I showed before explain with actions equals 1, where you can see the actions being run, the directed acyclical graph of the actions. So that's how it differs. Yeah. This is showing you the AST given the query string syntax here.
Right.
So this is a
really the parse tree
overview. Exactly. This is the parse tree.
Yeah, thank you.
That you'd be dealing with in your select query info, right? So in that select query info, you have at the top level a select with union query. It has one child, this expression list. So the idea here is we walk this graph, and we can traverse the AST in whichever method you pick. You can make a visitor, or you can just traverse it manually. And then from that, we can get some important information that we can feed to some sort of index, right? So in my example, maybe like a full text search index here, because we can see that literal that cool is being searched for. So at some point here, maybe the part that I'm skipping over here is that we'd have some function that traverses the AST and gives us something that we can apply an index to. Does that explain?
Yes, thank you.
Okay, no problem. Yeah, so there are plenty more useful overrides. There are lots of cool things now we can do with our custom storage, because all we overrode was read, and we got a lot of power from that. So I just wanted to continue to show you some of the other things we could override. We can override write, and write has a very similar pattern to read, where you have a sink instead of a source, but the sync you call consume on, but this is identically, pretty much identical. We're giving ClickHouse a big red button, and instead of when it presses it, we have to give ClickHouse blocks. ClickHouse gives us blocks, and we can now take those ClickHouse blocks and do what we want with them. We can compress them in our cool strings way, and then write it to a file or upload to the cloud, one could say, or do all kinds of stuff there. What does this let us do? This lets us write this statement, and this statement will then work. So we can use ClickHouse SQL now to write our data, right? So you can now do summaries. I could have a group by in here, so I could take the result of my select query and insert into my into my cool strings DB. Or of course, we could also get raw values using values. We can also leverage ClickHouse's mutation capabilities by overriding mutate. What this will let us do is mutate our data block by block. So we can, this lets us run alter table, update or delete, and using the handy mutations interpreter, which is a class, the kind of standalone class that you can use, you can then interpret this with this statement is very powerful. It can have multiple updates and deletes in a single statement, and it kind of figures out, for example, if I'm deleting or if I'm updating a row that I then delete two statements later, then I don't need to worry about that. So it does its own optimizations there, and again, it's handing you sort of the cleaned up version. So I know I spent a lot of time in a hypothetical scenario. And what we've created, I admit, is somewhat useless. But I did want to come back to Hydrolix and what on the core team we're trying to do in order to build a high performance object storage DBMS. So first, I want to say that our core team is hiring. We're looking for passionate C++ developers who are interested in building databases. And if you've got some ClickHouse knowledge, you are definitely ahead of the curve. So please do reach out to me if you're interested. So let me pique your interest and kind of sprinkle some secret sauce here. I'll kind of just give a brief overview of some of the stuff we're doing. So our very talented CTO, Hassan Alayli, has worked for many years on a custom task scheduler and coroutine implementation. So this allows us to significantly reduce CPU and memory overhead when we're pulling data from the cloud, and that lets us run many async tasks over all the available threads, and it is a speed up for the basic pillar of our storage, which is retrieving our data and serving ClickHouse the blocks that it wants, as we saw. We've built data types and compression codecs. And we've thrown every white paper in the book at it. We've thrown a lot of tricks at it, and we've seen some really good results in terms of how we can compress. And we've also built indexes for these data types. And these indexes are specific for block retrieval for the cloud. So just as we talked about in our toy implementation, where we're able to gather information from the AST and use our custom data types and our indexes, and we can use that information to apply predicates and downsample our data that we're grabbing from the cloud and create ClickHouse blocks on the fly for using the information we gather from our query and our custom indexes. Of course, I have to mention that we are using SIMD mainly because I think that adding this to a slide increases my performance by 200 times. So just gonna put that there. And I also want to mention an important point that the way we are storing data allows us to distribute the computation of a query amongst many worker machines. That lets us scale in a stateless way, and we can handle terabytes of data a day. And we do have real customers, some of them spending all day on pages of dashboards that when you load one of these pages, it runs hundreds of queries concurrently on our system. And yeah, they're seeing good results. They're seeing good performance and of course, low costs. So that concludes what I'd like to talk about today. And yeah, I just want to say that at Hydrolix, we are huge believers in ClickHouse. We've built our whole platform on top of it. So yeah, I'm really grateful to get to talk to this community specifically about some of the stuff we're doing. Yeah, so we can move on to questions. And I know there's a lot I didn't cover, so you can reach out to Marty or Hassan or me if you have any kind of more in-depth questions.
I wonder if I could just, hey, by the way, anybody who has questions, feel free to post them. Includes on out there in YouTube land. Yeah, quick question here. One of the big challenges that you have when you're working with pulling data off object storage and is getting it in fast enough. And can you comment a little bit on your general approach to that? I mean, there was a very interesting talk by the Firebolt folks a few months ago that talked about their approach. How do you guys get adequate performance out of that?
Yeah, I mean, like I said, we are seeing adequate performance, and it has to do with that downsampling that I mentioned. So because we've built these custom indexes and because we're operating on them and kind of significantly doing these push down predicates, we're getting only the data we need, and honestly, it's not our bottleneck. So got it.
So you don't depend, for example, on a local caching layer to the way Firebolt does?
No.
Okay, that's cool.
Yeah.
Great. Here's one from Minwei. Can you comment more on the SIMD for index on cloud storage?
Yeah, I can comment a little bit. That was, I mean, it's not a joke. We are using SIMD. SIMD is not always the right answer, and we're very aware of that. Just because you add SIMD instructions to something doesn't automatically make it faster. For example, it's very important that you are not mixing instructions. So you want to make sure that you look at the machine code there, and that you're not that your instructions are purely vectorized instructions, because you can get significant slowdowns if you start mixing them. Yeah, our compression codecs, especially, and decompression codecs are using SIMD instructions to kind of make sure that we can decompress stuff as quickly as possible.
Okay, I don't see any other questions, so I think we can keep rolling. Federico, thank you so much. I really appreciate having you guys come here, and plus the tour of how to embed a new storage engine was totally cool.
I'm glad. Yeah. Thank you.
Great. So next one up is Tim Spann, who's going to be talking about Apache Pulsar. So Tim, go ahead and take it away.
Sure. Let me share my screen. Hopefully all is visible. I know things get weird when you have more than one speaker, but hopefully this is showing up.
Perfectly.
Yep.
Looks beautiful.
So now for something completely different. I'm talking about fast streaming into ClickHouse, which also seems like it'll work for Hydrolix with Apache Pulsar. I'm Tim Spann. I'm a developer advocate here at Stream Native. I try to show people best ways of building some of these streaming apps with something I call flipping. I put extra letters in there when I find other cool things I put in there. Maybe I think I call this one Flip C. I don't know. There might be a better way to put the ClickHouse in there. Been covering streaming and different kinds of large data, different data for the past 15 or so years. Cloudera, Pivotal, Hortonworks, a bunch of other guys. I put out a newsletter every week, Flipstack Weekly, try to cover all the cool open source projects, plus some tools, tips, demos, slides. Like my Meetup stuff will go there, demos, GitHub, all that kind of fun stuff. So today I'm going to cover Apache Pulsar, which is just now in version 2.10, which has a couple of cool features in there. Show you some code, do a demo, show you how easy it is to just every event that comes in the system just streams right into ClickHouse, no coding, don't even have to think about it. Just runs as a Pulsar sync, pretty easy. And make sure everyone knows, may the 4th be with you every year. So Apache Pulsar is open source. It is cloud native, handles messaging and streaming. That is 2 slightly different things, but we support both. And what's nice about that is with having the right APIs you need to do whatever kind of programming it may be, regardless of the scale, things like microservices, very easily supported within Pulsar. If you do simple pub sub type programs like old school JMS or AMQP or Rabbit or anything like that, we support that. We also support different types of streaming. So if you use the Kafka or Kinesis, we support that. And by design, it's designed to work with multiple tenants on one cluster and being able to run an instance that spans multiple clusters, having built-in geo-replication, really designed for spread out and streaming in multiple clouds. Stream native IO is crashed. Uh-oh. Let's see if there's a typo here. Oh, great. I'll harass somebody on that. Thank you. That's very special. Someone didn't pay the bill. It's probably some kind of localized cache. I'll harass somebody on that. I don't know if David's still on the call to harass people on that. But generally we're up. But if not, just go to pulsarapache.org. Everything we're showing you today, open source. We're very keen on keeping it open source so you could run a full platform, including Kubernetes operators, Helm charts, Docker containers, whatever, however you want to run this, pretty easy to do so. My example app today, I've got NVIDIA Xavier sitting on my desk just out of reach. That's running a little machine learning app. It's taking a picture of some stuff on my desk, maybe my head, I don't know. Different things in the room here. Takes that data, runs some computations on it, gathers some data on the device, formats that as JSON, does a native call to Pulsar. I get it into my little cluster sitting in my office or sitting on the cloud, depending on my mood. And then from there, I've got a sync that automatically streams that to ClickHouse. I happen to be using Altinity's web hosting for that. I ran it in Docker. You know, I could run my own cluster, but Altinity's is really easy to use. So I'm very happy to use that. So that's pretty cool. I'm also doing a couple of other analytics on the data, you know, while it's streaming. Just as a thing, I'm using Spark SQL, Flink SQL, also Presto SQL. I didn't put that in the chart. Why do you want to use Pulsar? We mentioned that multi-tenancy is a nice feature. So I can really securely set up different companies, different groups, different applications within one cluster, and they're all secure. You don't have to worry about naming. You set up a tenant, namespaces underneath it, topics under there. You can have hundreds of thousands of topics, not have to worry about it. Scalability, so some of the largest companies in Asia are using Pulsar at pretty enormous scale, especially when paired with Flink SQL. Geo-replication, really easy to set up some configuration, just sends that data around. Very helpful if you're in multiple availability zones, or maybe you've got something on premise and you've got stuff in the cloud. Whether it's something simple like backup or as a way to, you know, replicate your data around. One model for all kinds of messaging, keeps it simple. So if you've got people want to do IoT messaging, you got people want to do microservices, work queues, Kafka style in order event streaming, CDC, you could do that in one cluster, set up different tenants, makes it very easy to do that. Data durability guaranteed. And what's nice to make it cloud native, the part that handles compute and storage are separate layers, very easy to scale them up independently, very easy to have the data tiered out into cloud storage, And obviously with syncs, very easy to send whatever data comes into the system into ClickHouse or what other data store you have, but ClickHouse works pretty well. We support publish and subscribe, pretty standard for messaging. Producers send the messages, go into a topic. You know, you can have whatever payload you want in there. Usually people will have some kind of schema on it so you know what these payloads are. You set up a subscription so you can get your data as a consumer. This is where the flexibility really comes in. Lots of different ways to subscribe to messages, makes it nice there. So when I was talking about that multi-tenancy, we've got a Pulsar instance that could have multiple clusters on it if you need to. But under each cluster, I have different tenants. I name them whatever I want, keep them secure. So maybe some people only can access one tenant or one namespace under there. And as you see, you don't have to come up with ridiculously long names for your topic since you have this nice hierarchy you could set up. Those subscriptions, this is where the flexibility comes in to decide, am I doing streaming? Am I doing messaging? What do I want to do? If I do exclusive or failover, one consumer, I guarantee the order. Failover just allows if that guy blows up, switch to the other one. Pretty nice. Shared, it's free for all. Send in a message. Whoever can get it fastest, you get it. Do whatever you want to do. Great for work queues or traditional messaging. Key shared, a nice way to split the difference. You know, so everything in that key will be in order. So if I need to, like CDC is a perfect one for this. Each table, say, yeah, go to one consumer in order. And, you know, I can handle 100 tables at once, as many consumers as I want. Lots of different ways to do it, you know, options, which is nice to have. Lots of terminology. I'm going to skip through that because I don't want to do a 5-hour lecture on Pulsar. But a couple of unique things with Pulsar that makes it a little easier to adopt. If I told you, rewrite everything you have in Pulsar, I know that's a big shift and lift. I don't ever want to do that too. No one wants to have to rewrite code that works. So we have adapters that are native. Like if you look at the difference between the native Pulsar library and handler and Kafka one, you see it's not some kind of side thing or sidecar or, you know, partially thought out add-in. It is the way the system is designed to allow you to have these different protocol handlers, and people in the community, customers have come together and built these. There's one for Kafka, which we just announced on our cloud product. It's a nice way to do that. David, who was on the call, going through, is going to put out some really cool videos showing you different things you could do with that. But at a minimum, move your Kafka producer over to our cluster, use that same code and library, and keep pushing messages. Same thing. What's cool is I can push something from a Pulsar producer and consume it with a Kafka consumer or whatever consumer I want. So you have that really nice flexibility. Same thing for MQTT, same thing for RocketMQ, same thing for AMQP, which is generally RabbitMQ and a couple other brokers out there. Makes it pretty easy. Now, the main way that we're getting data into something like ClickHouse is through a Pulsar IO sync. And we've got a bunch of these for different things, you know, whether it's SQS, and we've got sources and syncs. And we've got one for ClickHouse that goes through the JDBC driver. Seems pretty quick. You can build your own. They're just Java functions, very simple to write. And well documented. Download it, add it to your cluster, and you're ready to go. Now you could use Stream Native Cloud to host this stuff, so you don't have to set up your own cluster. Not that it's hard to set up a cluster, but Stream Native makes it even easier. Uses Kubernetes under the covers, and all those are open source. And we support Flink, and I'll show you why we like Flink. And like I mentioned, we got that Kafka connector out of there. But let's show some code. You know, I don't want to sit here and slideware all day. So hopefully when we point the demo in our face, it will not blow up. It was working during the previous hour We'll see if I let it run too long and ran out of memory or something else, where we're going to take a look at that. And these are hopefully the takeaways when we see this demo work. ClickHouse is easy and fast. Apache is a great way to do this with Pulsar, and these syncs are easy. Let's see if anything's still working, nothing timed out. All the source code is here with all the example queries, how I set up the tables, queries I did in ClickHouse, my configuration from Pulsar to ClickHouse. You just have to put in your own credentials. How can I deploy this? Now, this could be DevOps automated, or I could do it through cloud consoles, but it's nice to have the simple, very easy to read commands here that just use this configuration file and the connector that I download from either Stream Native or pulsar.apache.org. And all that demo is set up for you to go. I'm going to start my code here. This is the application that's running on that Jetson. It's doing some analytics, taking a photo, doing some deep learning on it, assembling a message, sending that as JSON through the system, and we'll start getting them. The sync is automatically deployed, and it's currently running. I'm going to take a quick look at the status of that. Again, that could be in a dashboard, you could do it in a REST call, but it's a nice, easy way to do that through the command line. So records are coming, it's like one a second, one every couple of seconds, just for good demo purposes. And I also set up a Spark application. It's very easy to connect Spark to Pulsar. Just set up here. If you had different ways to connect, we'd have all that security there. There's the schema of this. Because I used a schema to put my data in, it is nicely formatted, knows all the names, knows all the types, makes it very easy to deal with. As data is live, it's coming into Spark. Now I could do ETL here. I could offload it to some other data set, maybe run some machine learning, things you do with Spark. Now we've got the same idea within Flink. The difference is Spark SQL microbatch, Flink SQL event at a time. So as events come in, we will see them. So I'm going to run a query. This interactive query is actually creating a Flink job, deploying it to my cluster, and analyzing, connecting to the Pulsar metadata, getting the information on that topic, and converting it into a table. And as you can see, we already got a couple of rows in from that. And you can see the details on that. So those are coming in as it happens. So as we get a new record, it just happens. So you can imagine when I deploy this as a full application, I could do things like join live streams of data, connect to maybe more static database tables, run machine learning, run any kind of analytics, whatever you want to do as those events are happening. And again, I could take those events, do whatever logic I want to do, and then push it into another Pulsar topic. And that Pulsar topic can be a sync to ClickHouse. So I'll have maybe that raw data, then my real-time edited data going into ClickHouse, which is nice. Over here, I've got Presto SQL. Now, Presto, cool tool, but how it's designed and used in Pulsar SQL is at a point in time. So what's in that topic this very second? What's nice with Pulsar, since I have that tiered storage, since I have that, theoretically, if I got the money, unlimited storage, I could query everything that's in there. Gives me a nice, simple way to do analytics as they happen without, before I get to maybe my cleaned up data that's in ClickHouse. But I do have my data landing in ClickHouse. Let's see how many rows I've gotten here. So 1,100, obviously not the biggest workload, but I'm very glad that Altinity give me some space. So I'm not, I'm not going to use all their space because I want to add a couple more rows here. So we'll see, make sure another row is coming in, and then I'll do a refresh. Hopefully, no, there it is. Nothing crashed there. Sometimes when you're running all the way from the desk over here to the desk over there, something gets lost. Yeah, we got a couple new records came in, so that's nice. And then I'm running my query here, which is insanely fast. I gotta love ClickHouse for that. I'd love to see this with more data, but I'm probably gonna have to ask people if I can have more space before I start sending millions of records a second into ClickHouse. And as you see here, very simple to do a max. Here I'm just getting the results of my real-time camera that did the deep learning to say, what's this a picture of? I'm really curious of all these things it thinks are in my office. Desktop, computer, and screen, I'll believe. I don't know where in my room is a chainsaw. I'm kind of scared there. I don't think I have a chainsaw in my office. I don't think I have a sewing machine. I'll believe I have glasses. TV, sure, remote control, Band-Aid, and a stretcher. So sometimes machine learning is not the best. And I'm also looking at the temperatures of this machine to see if it gets too hot, does it start giving me nonsense? You know, whatever you're going to do there. This is the cloud interface for Pulsar within Stream Native. Very easy, as you can see here. If I've got different tenants, which I do, I could just go to different ones to see what namespace is underneath there. Once I pick a namespace, I can go to that and then see the topics within that. Inside a topic, I can look at things like, you know, what's the storage underneath, who's using it, does it have a schema, all those sort of things, pretty easy to do. I've got that Flink app I showed you, Spark, the same kind of interface, Presto, same thing, nothing too fancy there. One thing I wanted to show is there's another interesting feature of Pulsar that I like, is that there is a WebSockets interface. So I can read to and produce and consume messages from Pulsar natively in WebSockets. So this is a single page web app. Again, that's in the source code that just does a WebSocket call with JavaScript. I'm just doing jQuery here, and it's just consuming them. I could also produce messages from here. I do that in forms. Just another way to get to your data. Pretty straightforward, but kind of fun when you're doing that. I see we have a question. I like questions. Let's see. How does Pulsar compare to Kafka in terms of data volume and cluster sizing? We tend to be smaller. Now, there's a white paper out that just came out on Pulsar and Kafka. I don't like to, you know, argue different projects, especially we're all Apache friends. We generally smaller. We started a little later, and our design is separate of the brokers in the front that handle messaging, handle, you know, sending data in and out, routing, all that sort of stuff. And the Apache Bookkeeper, these bookies are where the data is stored unless it's out in tiered storage. Performance-wise, we are very close. Sometimes we're better, sometimes they're better. You know, tomato, tomato. In the world today for streaming, you know, a few seconds here and there, a few microseconds, you know, depends on your workload. We support a lot of different workloads. So we don't want to say, hey, we're the other Kafka. We do Kafka natively if we need to. We do MQTT, we do AOP. We do our own thing. Tends to be smaller clusters, tends to be, you know, no problems with data volumes because you don't have to put that massive data store in every broker because the brokers are just doing that routing. So that's nice. Like Kafka, we tend to use Zookeeper for balancing the metadata. We just extracted that out in the latest version. So now you can use things like etcd or RocksDB. So you've got an option where your metadata goes, especially nice for Kubernetes. We don't really want to embed that code somewhere else. The separation of concerns with Pulsar is very nice. For sizing, are the biggest clusters for Pulsar of equal scale that you've seen for Kafka. Yeah, we've seen some of the large cloud companies in Asia doing, millions of records, 1,000 nodes. You're doing, petabytes of data in events as they're happening, and you connect that with Flink SQL, so you could do, like a live data lake in memory as these events are going around. So scalability is nice. Again, if you're doing Kafka already, very easy to try this. You could use those same libraries or learn the Pulsar ones. They're pretty similar and, maybe a little cleaner. We started a little later, sort of like Spark for Hadoop. Support for all the major languages there, whether you're doing Java, Python, Go, Scala, Kotlin, Node.js, C#, C++. Most of the languages are there. The top three, though, that we support are Java, Python, and Go, and we support writing functions in those. Pulsar functions are kind of cool. They're the basis for these sources and sinks. And you could do things like, as an event comes in, do some processing on it. Again, similar to Kafka Streams, but we give you a way to host that, whether in the broker, in your own environment, in Docker, in Kubernetes, or in something we call function mesh, which is a separate Kubernetes space to run it. Pretty straightforward. We tend to be used for, IoT data, logs, REST data, CDC. Fast sources of data are really easy with us. And again, things like clicks, it may go into ClickHouse very easily. Very good use case for us. So again, a nice fit between doing ClickHouse and Pulsar together. And I've got information here on how to do it with the examples for the demo. Always expecting things to crash because I lost my network or, some tragedy happened on the internet, as we saw the website or the SSL version of the website for Stream Native is having a cache issue, at least here. I'm seeing that in the East Coast. I don't know if you're seeing that somewhere else. I don't know if there's any other questions. I could show you more, but I wanted to keep this nice and clean so we don't have a 9-hour meetup. Having done a lot of meetup, including running my own here in Princeton in New York, people got things to do. Maybe you don't want to be in a meetup for 7 hours. Though in person, a little different because you get that free pizza. Any more questions out there?
Hey, Tim, I got one for you. So can you talk a little bit about your JDBC adapter? Do you have like a generic JDBC adapter that works for any JDBC target?
We have a couple of targeted ones and the information how to write more. We tend to like to have ones that we've tested and specifically distributed. So you see here, there's only a couple because those are the ones people have put out in the open source right now. And there's some that go through Debezium. The code is very simple. And if you want to just fork it and put your own driver in there, we tend not to want to put those out there without someone testing each one. So that's why there isn't a generic one. Like we put the ones people like. These are the three top ones. It's ClickHouse, MySQL and Postgres. And then, we add Oracle in the Debezium one. But if someone's looking for one, if you looked at the source code, it's, put the driver name in, it could be made generic. Is that the best for performance and stability? I don't know. I like that,
That's exactly what I was asking, because if you have a generic one, it's not going to know that, hey, ClickHouse really wants to have this stuff in batches, for example. And yeah, okay. So that's something we can go look at the code. And
yeah, the ClickHouse one is specific to ClickHouse. If you guys want to add some performance enhancements, that's always great. Again, everything's open source. We're Apache based for all this. We're always looking for more committers. It's definitely, take a look. If you know a better way to do it or have a different driver you want to do, definitely reach out. We can provide some assistance.
Sure.
Not a bad idea. It's fast, but I haven't tested it at the million event a second scale.
We have a question from Kanthi. What were Kanthi, you can just go ahead and speak. I think you have audio.
Sorry, I was just trying to figure out where the sync connector source code is. Is it inside the Pulsar GitHub project?
Yes, this is it. We can take a look at it. It's really simple. Like, that's it. Because we have that base. That's what I was saying. You want to add your own. We didn't, we tested it. This one worked. That's why we put it out there. But yeah, you can see not much to it. It's just using the base one. If you wanted to write your own from scratch, or you saw some things were missing, I didn't see any problems. If you have any special things with extensions to JDBC, or maybe there's some type conversion stuff that can be optimized, or maybe there's a better driver, you definitely take a look. It's in the main project now, but yeah, if you did it externally, it doesn't matter where the Pulsar IO comes from. It's well, once it's built, it's external, so you can just add them. It's very extensible, so you don't really need to. It doesn't need to be here. At some point, maybe we put that somewhere in a separate one. Up to you. If you want to start a fresh one and maybe not extend from the base JDBC sync, if you have best practices for JDBC you want to use, or a different driver, or again with the Pulsar functions, it doesn't have to be follow what we're doing for the existing ones. You could use something else if you want. Pulsar functions are pretty straightforward. I could show you some examples because we got some extra time.
Hey, Tim, we got a question here, which is, hey, this is somebody's going back to the classics. It's coming off YouTube. Does JDBC ClickHouse Sync support exactly once semantics?
And by default, yes. Would I guarantee that, knowing that it's a generic JDBC driver? I don't know if I think I would want to write a custom driver for that to make sure. But if you set up and make sure that the consumer is set up for the right type of subscription by default, so to make sure that's true. But if we set up the subscription to be exclusive, yes, it would be guaranteed. Do I trust that generic JDBC driver? I don't know. If it's something critical, I'd want to put a custom driver in like we have for the Debezium ones. Mm-hmm. That might be, I'd want to make sure if you've got a real use case where you can't have, at least once, because I'm sure it's at least once, but exactly once, I want a driver that's very specific to make sure that happens,
Sure. Yeah. What's you've mentioned Debezium a couple times, and I'm just curious, how widely do you see that? Because we're using it ourselves. I'm just really interested in.
Debezium's everywhere, man. That is probably the only really well-maintained CDC out there. There's another one in Asia that's got a couple of good drivers, Canal, but Debezium is solid.
Cool.
Can't fault using Debezium. And what's nice, I didn't mention this because I hate to say don't use the native connector. If you don't see one of the Debezium drivers and you don't want to have to write 4 lines of code, because we have the protocol handlers for Kafka and support for Kafka Connect, theoretically, you could just use one that was written for Kafka. Mm-hmm. But, it's nice to use native whenever you can, but don't have to. That's kind of the nicety there, support most types of stream in there.
Good. Hey, just want to ask people, any more questions on this talk? Feel free to post them. The other thing is, if you have questions about ClickHouse in general, this is like open season now. We've got one of our support folks on. there's a bunch of people on this call who've used ClickHouse pretty deeply. So if you have questions about ClickHouse itself, feel free to shout them out and we'll do our best to answer them.
That's very cool.
Yeah. So by the way, thank you, Tim. Love the talk. And yeah, thanks. By the way, thanks for the shout out on Altinity.cloud. I'm glad it's working.
It's almost too easy, you know, because the amount of ClickHouse knowledge I have is much less than I should. And to get up and running and create tables and queries and have them all run fast, she's kind of genius. I'm very, very pleased with it. If I had a free Altinity cloud forever, I wouldn't complain about that. It'd be a nice place to put a few hundred gig of data.
Great. Okay. So with that, any questions on ClickHouse in general? Any other topics folks would like to discuss? And if you want to get unmuted and talk, if you have questions coming off YouTube, feel free to throw them out. We'll hang around for a bit and take general questions.
Sorry, one question about writing a custom Pulsar connector. Is that very different from writing a Kafka connector?
No, for the JDBC one, it would be simpler. I mean, it's really base level Java code, and we already have those documented examples we showed, so it's pretty easy. But again, Pulsar does support Kafka Connect if you wanted to. I mean, the Pulsar IO functions are really simple. Like, I've done both. I came from Cloudera and I was doing some Kafka Connect. It's easier. It's a really simple API. If you've done Spring or anything like that, I could show you a function just to give you an idea. That's the basis for these. This is an example. There's a Maven archetype to build this. We'll have a Gradle one too. All you gotta do is extend this function. It's one thing here. And if you didn't want to extend that function, you don't have to. And then you just have one method process, whatever type you want to come in here. That can be bytes if you want to keep it generic, or it can be an object, you know, based on a schema or a string, different payloads. Context, we give that to you so you get access to things like input and a logger, that kind of stuff. And this is all I do is do whatever coding and whatever generic Java stuff. And then at the end, either I can return that to the same topic, or here, especially if I want to send it to different topics like I'm doing here, take that context, send a new message somewhere else, and it could have a different schema. I could create a schema on the fly. Pretty easy. I mean, there's no, if you could write Java code, but this one's not rocket science here. Here, I'm not, if I return something, this would be the output to go into my output topic. But here I'm just deciding what topics I want them to go to in here. Pretty straightforward. Standard Maven. All I need is like, this is it. That's all my main dependencies. These are ones this one I'm using to parse some JSON and XML, and then some testing. What's nice with the test suite we have, we've got it so it'll, besides doing unit tests, you could do an integration test that simulates having a function runner, runs the full thing for you so you can see how it works in the real world, even support security if you want to connect to our cloud. Pretty straightforward there. Nice way to do that. You know.
Okay, any follow-on questions to that, Kanti?
No, I'm good. Thank you.
Great. We've got a ClickHouse, general ClickHouse question from Ramazan. When will storage and compute separation happen in ClickHouse? It's going to be a while, and if you go look at the roadmap, and let me just post the link in the chat for folks who are on Zoom. It's issue 32513 if you're on YouTube and want to look it up. That has the 2022 roadmap, and there were 5 things for separation of storage and compute. The first 2 are already done. Parallel reading from replicas, which is a pretty big deal. I actually haven't tried it, but that's a really powerful feature that allows you to take advantage of the fact that you actually have replicas so that you can partition your query and run it on different, sort of farm it out to different replicas. Dynamic cluster configuration with service recovery. The big one here is number 3 on the list, which is caching data from object storage. If you look at what it takes to get performance on object storage, I mean, there's different approaches. Federico kind of hinted about what Hydrolix is doing, but one of the standard ways to handle this is just to suck stuff in from object storage and then have it present on a really fast cache, for example, SSD backed. And that's the approach that people are taking on ClickHouse right now. There's a couple more things, but I think that caching is actually from the performance, just to get raw performance. That's definitely something that is really important to boost reads off object storage to get to the level of performance that people really expect for ClickHouse. So I think we'll see this coming over time. It's possible that because of the work in most people who are running cloud services are very interested in this topic. So I think there will be more stuff pushed into ClickHouse to help with this feature. I actually have to say at Altinity, interestingly enough, we are not pushing this very hard. And the reason is that we're very focused on ensuring that whatever we put into our cloud is compatible with Kubernetes in general. And actually, if I had, my wish list would be, and one that is on our roadmap, is to be able to use fast local storage effectively in Kubernetes. That's still an issue when you're running data on Kubernetes, is that it works great with block storage. You can read from object storage because anybody who can see, like S3, for example, can read from it, but actually managing NVMe SSD that's on local disk is a little bit trickier because of things like, hey, I want to rescale the pod. Or I have to move the pod to another host. How do I make that happen efficiently, especially with large amounts of data? And that's something which is sort of at the frontiers of storage management in Kubernetes. Good. Any other, let's see, any other questions?
Actually, I was wondering on your, this is, on your talk, histogram was pretty slow. I'm wondering.
Dog slow.
I think maybe it's the choosing of the buckets, like I think it uses decision trees or something to choose the bucket. Yeah, I'm not, because I guess if it's 6 times, it was 6 times slower, right?
Yeah, it was quite a bit slower. Well, part of it is that it's doing a sizing. My guess, I didn't go look at the code, right. And that would be the first thing to actually get an answer is like when you're really stuck, go look at the C++. There's probably some hints there. But my suspicion is because of the sizing calculation they're doing, it's just way more expensive to maintain that, computationally more expensive to maintain that that object, because it is maintained. One thing I know for sure, it is maintained in memory. You're not doing more I/O to do this. But the difference is, of course, a count is super. I mean, that's just just ridiculously cheap to do. It's a very you're just manipulating a very, very small amount of memory, whereas a histogram is clearly doing a lot more work. So there are some of the, just in general, some of the aggregates in ClickHouse are really, very, very slow. They are the bottleneck. The one that we have spent a lot of time studying is uniques, where there's just a huge variation between the performance of, uniques are to get, distinct values, for example, by day, or distinct number of, unique website visitors is the canonical use case. Those are just slow. And depending on how what sacrifices you're willing to make about, can it be approximate? Can I only count up to a certain number of people? You can get that to run a lot faster. But if you want exact results, that one is dog slow.
Of course, yeah. Yeah, we've looked at a lot of them as well.
Yeah, because you're maintaining a big old hash table. In fact, a lot of hash tables, and then it explodes if you have a lot of group by keys. Cool. Any other topics to talk about before we close up? All right, great. Thanks. Well, let me do one quick check. Give me a second. Let me just check out on YouTube. I forgot to look if there's somebody out there. I hope you guys aren't here. Hang on a second. I got to go find my YouTube. Let's give them once our live streaming. Oh, here we go. Oh, thank you. Okay, Constantine, does Altinity Cloud support automatic resharding? Answer to that, no. Why would you think that? No, I'm just kidding. No, this is and automatic resharding is, when I first started working, working at Altinity, the first thing I did was I walked over to Cloudflare because I was hoping, okay, they're big, they have money, we should be able to sell them something. And I said, what are your problems? And the first one on the list was automatic resharding. That was 3.5 years ago. It's still a top level issue. So right now, what we do is if people need to reshard, we actually help them move the data, because you can move. It's fairly straightforward to move parts. The fact that they're immutable makes them not too difficult to move. But ClickHouse, I think the dream, obviously, anybody who's used Cassandra really wants to be able to just pop another node in and have the data rebalance automatically the way Cassandra does. ClickHouse does not do that underneath, and as a consequence, our cloud doesn't do it as well. Over time, we'll probably add tools to help with that, but there's definitely some work that needs to happen inside ClickHouse itself. And it's a complicated problem. If you're familiar with this, you have to have an algorithm that allows you to divide up the key space so that you can have a notion of, hey, when I add a, like if you have like a primary key, which identifies data or characterizes it, and, as soon as I move another node in, I can take a slice of the key space and just move all the rows from that over to my new machine. ClickHouse does not have this structure, so it makes it really, the notion of a partition key space doesn't exist yet. Oh, are there any string specific? Hey, this is one that you may know, Federico. Are there any string specific encoders like prefix coding, for example? I actually don't know what that is. Does anybody know the answer to this? This is. Are
you asking like about a function, a string function?
Yeah, it's called, are there any string specific? This is from Federico Soave. Thank you for this question. Are there any string specific encoders like prefix coding, for example? Oh, I think I know what this is. This is, okay, if you're asking, is there a codec?
A compression codec.
Yeah, the default codec the only codec that exists for strings is dictionary encoding right now. Other than that, it's just compress the daylights out of little guys and also get them sorted right so that you get better, so you get better run length behavior. I don't know. Hey, Federico, have you guys done any work on that? I mean, because you guys are extending this. I don't know if that's something.
All of the above. Oh no. I mean, run length encoding, dictionary encoding, and
yeah,
or all things that we do. Yeah.
Yeah, you should. Yes, exactly. So this is what I thought you were saying, Federico. It's two Federicos here. This is getting confusing. You store the string as a paired prefix from the previous one plus postfix. This is like a delta encoding. And the answer is right now in the open source, it is not supported as a standard codec. As far as I know, that sounds like a great one for somebody to add in. Check the issues. Somebody may be working on that. That's a typical community distribution. We are not working on it. That I can tell you. Okay. Do you think? Here's a great question from Ramazan. Do you think that if all S3 disk features, including zero copy, S3 cache, etc., become production grade, then we may not even need automatic resharding? Yes and no. And I'll just give you my take on it. One of the issues is that in the end, yeah, object storage is great. We love it. I mean, and you guys have made a big bet over it on Hydrolix, but the fact is, for an awful lot of people, they need to run on local storage because it's pretty darn fast. And so in those cases, and that includes a lot of people who are running in on-prem environments, resharding is a big deal, because they need the ability to, to rebalance, to have a series of drives that are with attached storage. That's still a really good model because it has very consistent performance. So you definitely, in that case, want resharding. The fact is that even if you have everything in S3 storage, there are some real nuances to how effectively you can grab the data. So in that case, there's also still some placement issues. But I don't know, Federico, you may be able to comment on that. The Firebolt folks did some very interesting work to build a consistent cache from from S3 that partitions data efficiently across hosts. So there's still some kind of interesting work to be done there.
Is that what do you mean by placement issues?
Yeah. So, well, I'll give you an example. That if you look at the way that based on their talk in last December at Andy in Andy Pavlov's series, they have a cache which they built for from S3, and one of the properties of that cache is that you may have, let's say you have 3 nodes in a virtual in one of your virtual data warehouses. They will guarantee that a row or like a block will only be in one. It will be in one and only one of those caches, and they're able then to partition the query very efficiently. But achieving this required them to do some really, pretty delicate work to having to do with cache consistency as well as guarantees of what was in cache and what is not. So it's a kind of interesting. So what I mean is that having everything in S3 is not always a panacea, that you may need to do other things to make that model work.
Mm-hmm. That's very interesting. I mean, it sounds somewhat similar. Yeah, I think that, like you said, we're betting on the cloud, and and we're kind of taking the approach with our custom indices and our custom data types, and basically how we partition the data. And we are time series only, so that does help things a little bit. Cache consistency is not something that we've had to. It's not a roadblock for us. It's more about taking predicates and applying them directly.
Right, and you just do push down. You're more sort of a like get the stuff arranged correctly in S. If I understand it, and I'm not saying anything that hasn't is you're more focused on just doing push down so that you can do this efficiently.
That's right. Yeah.
Good. Great. We're running up on 2 hours. Unless there are any further questions, I think we'll close up. I would love to thank both Federico and Tim. Thank you so much for the talks today. They were both great. And if you are doing something fun with ClickHouse, or even something not fun, we would love to hear about it. Next, we have a couple of, as I say, we have a couple topics in mind for our next meetup. One having to do with replication out of MySQL, which is some work we're doing. Also have a new log management implementation. Actually, a guy who's pretty active out on the MySQL, or not the MySQL, that's a previous life, on the ClickHouse Slack workspace. He is going to come in and talk about some of the lessons that they've learned from working with ClickHouse to build a log management system. So he'll be on, and we have room for another talk. So love to hear from you guys. So with that, I'm going to call it good. Thank you, everybody. It's wonderful to meet with you guys, and have a great 2 months until we meet again.
Thank you very much. It was a pleasure.
Thanks.
Thank you.
Yeah. Bye, everybody. Talk to you soon.
Guys, appreciate that.